Hello, everyone, and welcome in to what we are affectionately calling episode 2.5 of our Constellation Crew series here at the Brown Planetarium at Ball State University. As always, my name is Greg Gallagher. I'm a graduate student here at Ball State University, and joining me today, we have Madeline and Riley, who are also fellow graduate students here at Ball State. How you guys doing today? You guys doing okay?
It's
Pretty
fun.
good.
Yeah. Hey, Thanksgiving is right around the weekend. We've got a short week next week, so I am ecstatic. Like,
Pump.
you
Same.
have no idea. But as we start our sort of tour of the night sky again, those of you that joined us last week might have noticed that we had some technical difficulties on our end here, which is why we are affectionately calling this episode 2.5. But as we start our view tonight here in the night sky, we are using the program Stellarium. And with Stellarium, we can simulate any time of day and anywhere in the world, which I think is kind of amazing. We can fast forward through time, we can reverse time. It's just one of the best programs out there. And so we're starting here in Muncie, Indiana, where Ball State is located. And we're starting looking in the south, right? And right now in Muncie, it's about 5:03 in the afternoon. So if you notice, since we're facing south, right, here in the west, you've got the sun still setting, right? So we can't really see a whole lot. But, excitingly enough, we can fast forward through time. And as we do, we'll notice that the sun is setting and it's getting a little bit darker, right? We can fast forward a little bit more. And as the sun starts to set here in the west, if it was a very clear night, right, we would start to see these very bright objects. So you can kind of see two really bright objects. You might be able to see a third bright object, right? So a third one that's kind of in between these two. But what are we looking at here, Riley? We've talked about these before, and so what are we looking at?
We're looking at some planets. So the one that's closest to setting, that is the brightest object in our sky besides the sun and the moon, and that's Venus. And it's so much brighter because it's so much closer to us. And then the other two are a lot further away. And we've got Jupiter and Saturn.
Right. So
which I think I said that backwards when he was pointing them out. So
all good, all good. So which one's Jupiter?
Jupiter is the one, that you're pointing at right now.
There we go. Right. So we've got Jupiter, right? We've got Saturn, which is significantly dimmer. So why is Saturn so much dimmer? Remind me.
It's because it's a lot further away from us.
Got you. Right. And what's special about Saturn?
Scott,
you know, Madeline?
Do what?
I was just asking Madeline if she knew.
Oh, gotcha.
Oh, yeah. So Saturn is famous for its rings. I mean, it really, as Beyonce once famously sung, Saturn really puts a ring on it.
That is true. Right. Absolutely. Love the Beyonce reference too. Like I'm feeling it. Yeah. All the single ladies. Yep. So, Saturn has its rings, right? Which is why it's super distinctive. We know that, right? But is it the only planet that has rings in our solar system?
No.
No, right? So what else has rings?
All the outer planets.
Oh, all the outer planets. Go Madeline, right? But what makes Saturn special then? So if all of the outer planets have rings, what makes Saturn so special?
They're actually visible. A lot of the other rings, you can't really see them without, like a special kind of telescope, but Saturns are very dense. So
yeah, because like if you take your like run-of-the-mill like like amateur telescope, you'll very, very easily be able to see the rings on Saturn, but it takes a much more high-powered telescope to see the rings on Jupiter, Uranus, and Neptune.
Gotcha. Nice. So as we fast forward time, All right, we're at about 6:45 now. The sun is set, right? And we're starting to see a lot more stars in the sky. But what Stellarium also lets us do is it also lets us turn off the atmosphere. So this is what we would see in the night sky here in Muncie if we didn't have an atmosphere, right? So notice there's a lot more stars that we can see. We have this band, and crew, remind me what this band is.
The Milky Way.
It's the Milky Way, right? That's our home galaxy. Perfect, right? And as we continue to fast forward time, we notice that there are other bright objects in our sky that we start to see, right? And there's a very well-known bright object, and Riley is smiling because she knows exactly where I'm going with this, right? But there's a very bright object here in the southeast, right? And it's making its way across the sky. Everybody knows what this is, right? So what is this, Riley?
We're looking at the moon.
We are looking at the moon. I love it. And on November 19th, right? So today, the moon is in what phase?
So it is in a full moon right now. So the moon, as obviously you guys would know from looking at the sky, doesn't always look the same. And that's because, as Greg said, there are different phases of it. And what phase it's in honestly just depends on the position of the sun, earth, and the moon. So if it's in between us and the sun, we don't see it, which is called the new moon. And then if it's behind us like it is now, we get the full moon because the sun is actually, the moon reflects the sun's sunlight. So that's why we see the full moon. And do you guys know why there's the phrase, the dark side of the moon?
The
So,
dark side of the moon, because Pink Floyd loves to make music.
Yeah, 70s were a rockin' time.
100%.
Love all the pop culture references that we're making here.
Yeah, perfect.
But it's actually because the moon doesn't rotate. It stays still and it just orbits around us. So we only ever see the same side of the moon. And that's why we have the phrase, the dark side of the moon, because we don't ever see it.
So it still rotates, right?
Mm-hmm.
But
yes.
It rotates with the same rate, right?
Yes.
Okay.
Yes.
Yeah, that's what. Yeah. So you exactly right. So the moon rotates, but it's at the same rate
that it orbits.
Yes. What does anybody know what we call that orbit?
Is that are you referring to the phrase tidally locked?
We can refer to that.
Is there a different phrase for that?
I was thinking of a geosynchronous orbit, right? But either
way.
Yeah.
Either
way, it's the same thing, right? So yes, the moon is tidally locked, right? Which is why that happens. But there are also some things like satellites, right? That we put in these geosynchronous orbits because we want to, we want to see them all the time, right? So, yeah. So something really interesting actually happened with the moon this morning, right? And Stellarium allows us not only to go forward in time, but it goes backwards in time. So I want to take us back.
Time travelers out here.
I know, it's perfect. So I want to take us back. We're at about 2:45 in the morning, this morning, right? And I want to center us here on the moon, right? So as time goes on, we'll start to see the moon getting shadowed, right? And right around 4 o'clock, the moon gets this kind of dark tint to it, right? So what is happening here? Why does our moon look red?
Yeah, so a big thing that happened was we had a partial lunar eclipse. And so right at 4:03 a.m. was the peak of it. And a lunar eclipse is when the sun, earth, and moon are positioned in a way so that the earth is actually blocking the sun from shining onto the moon. Mm-hmm. And the reason that it's that weird kind of orangish red color is because the rays of the sun are shining through Earth's atmosphere, and they're bending and refracting, and they're landing onto the moon. And because it's going through our atmosphere, it's giving it that kind of reddish orange color. So it's kind of fascinating how it works.
I just thought Mars got really close to us for a second. I don't know.
Isn't the kind of the reddish like tint of a lunar eclipse, that the reddish phenomenon, that's similar to like what happens when the sun sets and
Mhm.
turns redder, correct?
Exactly. Yeah. Yeah. So that's why it is that color. And it was actually also one of the longest lunar eclipses to have happened.
Hmm.
And it was 6 hours and I think a minute,
Wow.
but long time.
Yeah.
We love that.
And I think, Riley, you have a picture to talk about, right?
Yeah, yeah.
So,
So we can see it in Stellarium, but you can also go out and you can use a telescope and you can look at the moon yourself. So the picture that is showing, I took that, I think it was like 6 or 7 years ago at this
mhm.
point. But there was a lunar eclipse. I didn't have to go out at 4 in the morning. This happened, I think it was more at like 11 at night. So that was kind of nice. But yeah, I just have my own little at-home small telescope, and I was able to put my phone up to the lens and take it with my iPhone.
Wow.
Were you were you able to get a picture of the eclipse this time?
No, I actually slept through it, unfortunately, because I thought it was going to happen tomorrow morning, but it was also cloudy. So,
Right.
if you have any
Yeah.
suggestions on what to do if it's cloudy?
Yeah. So, unfortunately, those of us in Muncie, and I think a lot of Indiana too, because I think my dad wasn't able to see it up north.
Hmm.
Not very many people in Indiana were able to see it, but thanks to
Oh,
modern
chip.
technology, we got there are plenty of people across the internet who like
Hmm.
filmed it or like took pictures and upload them to the World Wide Web. So you may not be able to have seen it in live time, but you can see pictures of it.
Hmm.
So you don't have to have a complete sense of FOMO.
Yes, I would be irate. So, interestingly enough, though, right? So, if we speed back time, right? And speaking of pictures of our moon, right? Uh, we have two pictures to look at here, too. The first one Riley also took, right? So was
I
this one
like to take
taken with
pictures
your
of it.
telescope as well?
Yep, I did. I just like to take it out and show, different people that aren't in physics and astronomy how cool it is to see the moon and be able to see more of the detail of it.
Mm-hmm.
Um, but my telescope's fairly small, so you can't really get that zoomed in image, which I think Madeline has a really cool picture of that she can talk about next.
Yeah.
Yeah.
So Madeline also sent me a picture, and
Yeah.
this one is crazy. So
Yeah. So
go ahead, Madeline.
I like took this picture with my phone camera as well, but I had access to a larger telescope.
Mm-hmm.
I took this picture back in 2019 during an observational astronomy class. My alma mater, IU, has this historic observatory with called Kirkwood,
Mm-hmm.
and it's got this beautiful 120-year-old 12-inch refractor, I believe it is,
Wow.
and the larger size allowed me to get a lot more detail, which was a lot of fun.
Mm-hmm.
Yeah. It's cool being able to see the actual like texture and the craters on the moon.
Yeah, that's how you know you've gotten like a really like nice high quality image.
Yeah. Well, the amazing thing to me, honestly, is the fact that like even with the small telescope and the iPhone camera, right, you still can get a really detailed picture of the
Yeah.
moon. Um, but especially
Yeah.
yeah, with that one that you got, Madeline. I mean, just the craters alone, just the detail we can get with that is just amazing to me.
Yeah.
So
Got some great telescopes out there.
as we look at our night sky, right, and this is about 2:15 ish. Oh, I just reset the whole thing. No, sorry. So about 2:15 in the morning, we can start to see a lot of shapes, right, that are being made with these stars, right? And since this is Constellation Crew, right, figured it would be important, right, to talk about some of the constellations you might be able to see, right? So if we turn light pollution in the atmosphere back on, we'll make it a little bit more realistic to what we could see if we were to walk outside, right? And we can see some very distinctive patterns, right? So up here next to the moon, we have a pattern that looks kind of like a V, right? Anybody know what constellation this is?
I honestly don't remember.
I was gonna say, I'm pretty sure you said it last week, and it's just slipping my memory.
Is it Taurus? Because
It
I
is.
remember when we
There
were
you go.
doing last week's show, we talked about the Taurid meteor shower, and I remember it was near the moon.
Absolutely, right? And then Madeline, we have a very distinctive line of 3 stars, right, down here. If we're
Heck
facing,
yeah.
again, this is facing south at about 2:15 in the morning, right? What constellation are we looking at there, Madeline?
So that constellation is my personal favorite constellation. It's Orion.
It is Orion. Yes, very
That
nice.
does
Right?
help.
So what we can do with Stellarium is we can actually pull up all of the pictures of our constellations, right? So like we talked about before, we've got Taurus here, Taurus here
Taurus?
in the southwest, right, toward the moon, right? You've got Orion here, very distinctive belt, right? You've got this star that's a part of this constellation. Does anybody know which star this is? What's that star called, crew? And what makes that star special? Do we know?
Really testing our knowledge today.
I am.
Yeah.
Yes. Okay.
Man.
So this star is Sirius, right?
Oh, wow.
Which is the brightest star in the night sky. And it is part of the constellation Canis Minor, right? Which is the little dog, right? Fun fact of the day for you, right?
Learn
So-
something new every day.
Exactly. That's the whole goal of Constellation Crew, right?
Even we're learning.
So as we, look through the night sky, we can find some other common constellations, right? You've got Gemini, Cancer, you have Ursa Major, right? The Big Bear. And we've talked about Ursa Major a few times now. What have we talked about it? So what about Ursa Major have we talked about? It's a weird way
We
to say
talk-
that, but whatever.
We talked about the Big and the Little Dipper,
Exactly,
which are
right?
asterisms that are part of Ursa Major and Ursa Minor.
Yes, very nice, right? So I love the use of the word asterism, right? Because an asterism, right, is not a constellation per se, right? But they're found in constellations. Asterisms, like the Big Dipper here in Ursa Major, right, are specific shapes, right, that we can see that everybody kind of knows, but that aren't constellations themselves, right? We do call those asterisms, right? So right underneath Ursa Major and right above the horizon, we have this lion, right? That's a constellation in the zodiac, right? So what's that constellation called, crew?
Leo.
That is called
Yeah.
Leo, right? Absolutely. And one of the best ways we can find Leo is if you look for a backwards question mark in the sky,
Oh, yeah.
you can see the head of Leo, right? Well, there's something special that's happening in Leo, right? So Madeline, what do we got here? So we're highlighting something called the Leonids. What the heck are Leonids?
So, kind of, the Leonids are actually a meteor shower, and I found it really interesting that there were back-to-back weeks of that had prominent, like meteor shower peaks,
Mhm.
and so the Leonids actually peaked on Wednesday with about 10 to 15 meteors per hour
Mhm.
in a dark sky,
Wow.
but you don't you're able to see these on more than one day, so even though it's been 2 days since the peak, you can still see them, which is really, really awesome.
Mhm. So what are
Now,
we talking about when we're talking about meteors?
Yeah, are you guys familiar with meteor terminology?
Oh.
I know a meteor is a meteor?
That's a
Like a piece
star.
of debris that is burning up in our atmosphere.
Yeah. Yeah. So there's a lot of like very similar sounding terminology. As you said, Riley, a meteor is basically a piece of debris from a comet or an asteroid that enters our atmosphere. It makes like a really bright flash. And if you are paying attention, you can catch it. And they can also be called shooting stars, which is a term I think you brought up last week, Greg, when we were discussing these.
Yes.
So shooting stars are meteors that are like really, really fast and bright. So they're the name for like the more spectacular ones. And then you have meteorites, which are meteors that end up hitting the ground. And usually that makes, when that happens in the modern era, that really makes the news.
Yeah.
And then finally, you have meteoroids, which are basically meteors before they've entered the atmosphere. So there you have it. You guys are meteor experts now.
There we go.
Thank you so much. So so we've got the meteors, right, that peaked on, what day did you say, Madeline?
They peaked on Wednesday.
Right. So they peaked on Wednesday. Can we still see them now?
Yes.
Now, yes.
But you got to go out to, I highly recommend going out to like as dark a sky as you can to be able to see these, because they aren't the most prominent of the meteor showers, of the common ones anyways.
So would we be able to see those like here in Muncie?
Maybe if you're lucky on the outskirts of town, but you really, really want to get to as dark a sky as you can, which unfortunately for residents of Indiana, there's not a lot of dark sky to be had, at least like sufficiently dark sky.
But there is a website that Greg will put in the chat where you can kind of search areas close to you, and it can maybe direct you to a sky that might be a little bit darker than Muncie, Indiana.
Yeah, because like not all of us are lucky enough to live like out in the Western United States, for example, where you have all these very, just lots and lots of like dark sky sites, but you can at least find the darkest sky near you.
It's a nice little tool to have.
Yes.
It really is. I spent probably 20 to 30 minutes last Friday, like looking at it with one of my professors to kind of like figure out where the darkest skies in Indiana are.
Alrighty, crew. So Riley has some very special invitations for all of our viewers.
Yeah, so we love that you guys join us online, but you can also join us in person for some shows at the Brown Planetarium. We have one tonight at 6:30 if you're able to make it. However, if you're not, we also have shows tomorrow, November 20th, shows at 5 and 6:30. And then we also have a more family fun show that everyone of all ages can see, and that will be at 3:30 tomorrow. So the ones tonight and later at night is Destination Mars, and it just kind of talks about how NASA's trying to get us to Mars and what they're all doing. And then the family fun one is called Earth, Moon, and Sun, and you'll just kind of learn more about how those three work together. And then also next weekend is Thanksgiving weekend, but we still will have in-person shows if you guys want to come out then as well. Same times, same shows as well.
Yeah, they're really good shows, so we highly recommend you come out and see them. And you might even see us in person, so that's cool too.
Yes, they are amazing shows. I've seen all of our planetarium shows, and I can honestly not overstate them enough. The planetarium staff here works so hard to make sure that every single show goes really smoothly, and they're just amazing. So highly encourage everybody, everybody that can to join us for any of our shows. Well, crew, I think that's it for today. We do not have Constellation Crew next week, right? So we do have the in-person shows, but no Constellation Crew next week. which means that we only have 2 more shows for the semester. So we've got one coming up in 2 weeks, and we've got one the week after that, right? So
it'll be December 3rd and December 10th.
So only 2 more Constellation Crew episodes. Where did this semester go?
That's a really great question. It's gone by too fast.
All right, crew, any final thoughts?
Honestly, have a great Thanksgiving, everyone.
Yes, absolutely. Everybody have a great Thanksgiving. Thank you so much for joining us today, and we hope to see you in a couple weeks. All right.